Another example of solving nonlinear systems using the substitution method would be working with the equation x minus y equals 3 and x minus 2 quantities squared plus y plus 3 quantities squared equals 4. So this is a line, and again this is a circle. And so what we want to do is, again, we want to solve this linear equation for an x equals or y equals to substitute into our second equation here. And so I'm going to kind of go off to the side. I'm going to solve this for x by just moving the y term over. And you can write that in descending order or not. It's up to you. And so now I know a value for x that I'm going to use to substitute over here. And so now when I substitute for x inside this parentheses, I get 3 plus y minus 2 quantities squared. And everything else is the same. I haven't done any work other than substitute for x. Now we're going to need to combine some like terms, and then we're going to need to do some algebra to expand. So here I have y plus 1 squared. And I'm taking a little bit extra time to make sure I don't skip too many steps. Now what I need to do is I need to expand out this binomial square. So either off to the side you can do an area box, something to expand out what this binomial square looks like. I'm going to use a little shortcut technique, which is square the first, 2 times the product, and square the last. And so this is a rule for binomial squares. Take the first term squared, 2 times the product, square the last. And I'm going to do the same thing for this one. Again, you can get this information also by doing an area box. You don't have to know the rule. So again, square the first term, 2 times the product, square the last term. And that is something that we learn in Math 2, but it's also an algebraic rule that we can use if we want to. So now I'm going to combine my like terms. I have a 2y squared plus 8y plus 10 equals 4. And now I need to move my 4 over to the other side, which is going to give me a 2y squared plus 8 plus 6 equals 0. And now since these all have something in common, they all have a 2 in common, I'm actually going to divide every single term by 2 to simplify this equation down a little bit. And what that's going to do is it's going to allow me a smaller equation to work with. And so when I'm trying to factor, this is a lot easier to factor than it is having larger numbers that have common factors. So numbers that multiply to give me 3 and add up to give me 4. -1 and -3 are my y values. But now I need to go and find the x coordinate that goes along with those. So again, I'm going to go back up to my first 3 plus y and solve. And so I get these 2 coordinates. Now be careful when you write your solution to the system that you have to put the x value first and then the y component on both.